Hello everyone, and you're welcome. In this section, we're going to look at how we can create arrays and look at some of the common array functions. So the first thing I'm going to do is to launch Jupyter Notebook. And once that is launched, we'll go ahead and start working with our project. So now that that's opened up, let's go ahead and start our project. So right here, I'm going to click on New, and yours might be slightly different because I have other extensions installed. I'll just click on Python 3 to get this started. So now that we have that new notebook, what I'm going to quickly do is just to save my notebook, and I'm just going to call that NumPy. I'll just say first underscore NumPy, just like that. So we have our document named. So the first thing I want to do is just to create a comment. If we're on this and I just press M, it's going to change that into a Markdown cell. So a Markdown cell is simply a cell that contains just text information. So first, I'm saying we're going to just import NumPy, and I'm going to use the shortcut B to create a cell beneath, and I'm just going to say import NumPy as NP. So now that we have that, let's just go ahead and run the cell. So let's run the cell so we can jump to the cell underneath. So first thing I like to do is to create a list of integers. So I'm just going to say, we can do a comment like this, C style commenting, and just say list of integers. All right, let's just say creating a list of integers. So I'll just go underneath, and I'll just say list underscore of integers is going to be equal to, and then in the list, I'll just assign some random numbers. I'll just say 3, 4, and 5, and I'll run that cell. So now that we have that, let's create a one-dimensional array, and then we'll pass that list into the array. So let's create a comment, or let's just say creating an ND array of one dimension. Now, an ND array generally represents a one-dimensional array, a two-dimensional array, a vector, or a matrix. Three-dimensional arrays are called tensors. It's just NumPy's way of calling an array. So when you see an ND array, it just means it could be one dimension or two dimension. So an ND array is a general term. So let's make that into a Markdown cell, and then we'll move on to the next step where we're going to create that array. So to create an array, we're going to create an object, and then we'll pass in the np.array function. So the first object we're going to create, we're going to say array underscore object, obj, just like that. And we're just going to say np.array. And what we're going to pass into it right now is our list underscore of underscore integers, just like that. And if everything is run smoothly and fine, that's going to be okay. So the next thing we want to do is to just print the array, just like that, and I'll make that into a Markdown cell. So next, I'm just going to say print the array underscore obj. So next, we're going to see we just have that array represented as 3, 4, 5, which is awesome. So that's how we can create an ND array. We can do the same thing by creating a 1D array without even passing a list directly. And let's see how we can do that. So here, I'm just going to say creating a 1D array. And just underneath, because we can pass that in a cell, let's just say 1 underscore D is going to be equal to np.array. And then we'll pass into our array with the curly, with the brackets first. Then we'll use the list constructor, the square and angle brackets, and then we'll pass in some random numbers, separating them using commas. If you forget to separate them with commas, you're going to have a problem. So here, if I simply print the 1 underscore D array we just created, we can actually see that. So that's one way you can create that. So if you have the list already, we can just pass it directly. But if we don't have it as a list, when you're creating the array, you have to put the brackets. Don't forget that. Now let's see how we can create an empty array. So let's say creating an empty array, just like that, and I'll make that into a markdown cell, and I'll just run that cell. So that cell is going to be empty underneath. Now to create an empty array, we use the np.zeros, and then we'll pass in an integer to represent the size of that array. So to do that, let's just say create an object called empty, and let's set that to np.zeros, and then we'll pass in a 3-dimension, just like that. So if we go ahead and print empty, sorry about that, whoops, and we run that cell, you can see we have an empty array that's initialized with 3 zeros. So that's how we can create an empty array. To create an array of ones, let's see, creating an array of ones, right? So we can create an array that contains just ones. We're going to use the np.ones. So let's just say create an object called ones, and then we'll pass in np.ones, like that, and then we'll pass in the size. So let's say I just want an array with a size of ones 4. If I go ahead and print that object, and I print out ones and run the cell, we can see we have an array with a list of ones. To create an empty array, we just let's say empty array, and let's just say creating an empty array, turn that cell to a markdown. To create an empty array, we use zeros, right? It's going to initialize an array with zeros. So let's just call that empty. It's going to be equal to np.zeros, and then we'll pass in the size of that zero array, and then we can go ahead and print empty so we can see our result. So now we have an empty array. Now we have an aRange method. With the aRange, it's going to actually create an array within a specific range. So let's see that. So creating an array with a range, just like that. So let's just say a range equals np.arange. We'll put our brackets and we'll pass in the size. So let's say 5. And once we've done that, let's go ahead and print the range. And we can see that we have an array from the range starting from the least number to the maximum number. Remember, it's 0 indexed, so it's starting from 0. So if you say 5, you're going to get the maximum to be 4 because the index of the first number is also counted. That's that. So we can also use a range, but with a start and a step. So let's say using a range with a start, comma, a stop, and a step. And let's see how we can do that. So let's say a range underscore 2. Let's create an object underscore 2, and let's just say np dot a range, and we're going to create a start value. So let's say we're starting at 2, we're stopping at 8, and we're stepping at 2. So we're using a 2 interval. So let's go ahead and just print out a range underscore 2. And I think this is kind of small, so let me just go ahead and just increase that zoom a bit. I just use Control and plus because this is a Jupyter Notebook runs on a web server, and when you hold Control and plus on a Windows system, you increase your zoom size, and then when you use plus, Control, and minus, you decrease it. Basically, I'm holding Control plus, and I'm just dragging that, and you can actually see it from right here, right? So we can zoom in and zoom out. So I just want to zoom in so we can actually see that. So now it started from 2, took 2 steps, 2, 4, 6, and excluded the maximum. So that's what a range does. Now another thing we're going to look at is the lin space. The lin space creates a linear space between a minimum and a maximum value, and then you provide an integer with an argument called num for that space. Let's go ahead and see that example. So let's say using lin space to create intervals, just like that. So what I'm going to do is just say lnsp to represent lin space, which is an object, and let's just say mp.lin space, all lowercase, and I'll create a start value, set a max value, and then I'm going to set num to be equal to 10 because I wanted to have that 10 interval. So if I go ahead and print lnsp like that, you're going to see it's going to create that value within that interval for me. So that's what linspace does. You can actually change the num value to something, say like 5, and then run this. So let's go ahead and just run it again, and you can see it gives you that interval with these values in between. So that's the thing we're going to look at in our first exercise is the np.dataType. So the dtype lets you change the type. So initially, when you initialize a NumPy object, it actually creates a float as the default data type. You can set it to an integer. So let's go ahead and see how we can do that. So let's just say creating an array and setting the default data type, data type to int. Just like that, we'll turn that to a markdown cell just for a comment and as a header. So let's just do that. So let's say create an object called data type. So now that we have the object called data type, let's say np dot a range. It's single R, not double R, or else we're going to get an error. So let's say I wanted to start at 3. I want to take a maximum of 6, and I want it to take one step. That means it's going to start from 3, and it's going to jump all the way to 6 by going to 3, 4, 5, and then stepping at 1. And then I'll set the dtype property, and I'll set that to np. I'll set that to np.int64, just like that. And if I go ahead and print data type, we should actually see the result just like that. So it starts from 3, goes to a step 4, another step 5, and then excludes the maximum point. So basically in this short lesson, we've seen how we can create, sorry about that guys, we've seen how we can create an array. We've seen how we can create an array using a list, right? We can create a list and then we can pass that. There are other ways to do that, and also we can create nested arrays. We saw we could create an array of ones, empty arrays with the a range and also linspace. In our other subsequent lessons, we'll go ahead and see what other functionality the NumPy array has, and we'll also be working with matrices and adding matrices together. So thank you very much for watching guys, and I'll see you in the next lesson.